All right, exponential growth. We're going to kind of use this problem to help us think about this, but we're going to consider a myth that a single piece of paper cannot be folded in half more than 7 times. Each time the paper is folded, the thickness doubles, and that makes sense, right? So we're working with paper that's relatively thin, which is at 0.07 millimeters thick. We're going to complete the chart. Now, it doubles in thickness every time, so we're going to multiply by 2, right, to get each of these values. So 0.07 times 2 gives me 0.14. Times 2 gives me 0.28. Times 2 gives me 0.56. Times 2 gives me 1.12. Now, we're going to do absolute and relative change, right, from the previous fold. So I'm going to start, and I'm going to do this one here in orange with you, and then I'm going to have you hit pause and try the rest. So remember, we're going to take new minus old for absolute, and new minus old divided by old for relative. So if 0.14 is new, then the one previous to that would be old, in this case 0.07. So I end up with a 0.07 absolute change, and that should make sense because you doubled it. So it just changed by the amount that it was. Now, when I take 0.14 minus 0.07 divided by 0.07, well, recall that you're going to subtract first, then divide. Anything divided by itself is 1, which gives me 100%, right? So there's your refresher on absolute and relative change. I want you to go ahead and hit pause, finish the rest of the table, and then come back and check to make sure that your answers match mine. All right, so you can see the absolute changes each time, but the relative change is always 100%. So we have 100% change. Now the model for this, when we talk about our exponential model, recall that you have the amount equals the initial amount, 1 plus the percent change raised to the time period. So our thickness, when we're thinking about our amount, the initial amount was 0.07. 1 plus the percent change. Well, remember, we had 100% change every time. Well, 100% as a decimal is just 1 raised to the x power. So we really have a formula, 0.07 times 2 to the x. Now, this 2 should make sense because, remember, our thickness doubled. And if you double, your growth factor is 2. Growth factor is the 1 plus the percent change. All right, so how thick would it be after 7 folds? So 0.07 times 2 raised to the 7th power, because the power tells you the thickness after the folds, or how many folds. So you would first start with 2 to the 7th power, then multiply by 0.07. So 0.07 times 128 gives me a thickness of 8.96 millimeters. And make sure you use your appropriate labels. Okay, so the myth was busted on Mythbusters. I like that show. It's pretty interesting. They made a sheet of paper roughly the size of a football field and used a team of people to create the folds. With the help of several people, a steamroller, and a forklift, they folded the paper in half 11 times. Okay, how thick was it after 11 folds? Now, they also want us to change it to inches, and we'll do that in a minute. So 11 folds. That's y equals 0.07 times 2 raised to the 11th power. So again, 2 to the 11th first, then multiply by 0.07, and we get 143.36 millimeters. Now, let's go ahead and go back to our conversion days. 1 centimeter is 10 millimeters. So 1 centimeter, 10 millimeters. So that right there makes my millimeters go away. And then they tell us 1 inch is 2.54 centimeters. So that makes my centimeters go, centimeters. So I'm going to take 143.36 divided by 10 divided by 2.54, and I'm going to have to write my answer here up top because I'm out of space, but it's roughly 5.644 inches. So you're taking a piece of paper the size of a football field. You fold it in half 11 times using a forklift and a steamroller, right? And you end up with something that's like, a little over 5.5 inches. But that's from that paper is thin, so that's kind of impressive. All right, we can use this model for trial and error to figure out how thick things are going to be. So how many folds would it take to reach a cruising altitude of 30,000 feet? And thankfully they tell us 9,144,000 millimeters. So we want to figure out what it would take to get to 9,144,000 millimeters. Okay, so if we do 20, if you plug it into 20, you get 73,400.32 millimeters. Definitely not enough. So we go higher and we go 30. Well, that gives us 75,161,927 millimeters. Too high. So we go lower, guess 27, and you get 9,395,240.96 millimeters. And recall, it's doubling every time. So if you would go to 26, basically you cut that in half, and that's going to be way too low. So it would take 27 folds of a piece of paper to get it to be 30,000 feet. And you think about, well, I can fold a piece of paper in half 27 times. Well, you really can't. You just run out of paper. So it's crazy of how that works, right? Now, according to the National Aeronautics and Space Administration, the average distance to the moon is 384,400 kilometers. How many folds would that take? Okay, first things first, we do everything in millimeters, right? So we first need to say, how many millimeters is this? Well, recall, to go from kilometers to millimeters, we would move right 6 places. So here's my decimal point, 1, 2, 3, 4, 5, 6. I have to add 6 zeros onto that. So that's how many milliliters I'm going to need for this problem. So I want to do the guess and check process till I get to this number. Okay, so 30, we know that 30 was at 75 million, right? Well, 75 million, that's only like right here, those place values. We need to get quite a bit bigger. So I started with 40. So if x is 40, if I make 40 folds, so again, we're talking about y equals 0.07 times 2 raised to the 40th power. I got 76,965,813,940. And you're thinking, is that big enough? Well, 3, 3, 3, boom, 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 76. I'm only right here. I need to get bigger because I need another whole decimal place, right? And you can guess and check a few times, but essentially 43. 43 folds will give me 616, and I rounded here, but approximately this, which is, you might say, well, that's too high, I only need 384. Well, true, but if you cut 616 in half, you get 308. And 308 is just not enough. So we've got to go, like 42 and a half would probably be okay. You get less than 42 and a half. But if you need full folds, 43 folds will get you to the moon. Which you might, again, it doesn't seem like that much because it's only 43 folds of a piece of paper. But remember, every time you're doubling. So it's just a fun thing to think about. And that's the end of this video.